Now we have up here to kind of talk about another dimension. We've been talking about a lot of the infrastructure in the company. Greg Degen, who's head of international affairs at Commonwealth Fusion Systems. Greg, welcome to the stage. And I saw Jim Baker. Where's Jim Baker? Where's Jim? Jim, you're still out there? Oh, there he is. I may be calling on you in a minute, all right? So just be forewarned.
Great.
Hey, how are you? Good to see you.
Steve.
Thank you so much for coming.
Thanks for having us.
I hope you've enjoyed. Have you seen any of the program today?
Absolutely. It's
okay, are you
saw
scared?
Jared, NVIDIA earlier.
Yeah, it's great.
Yeah.
So power, energy, and fusion. I mean, you know, I mentioned Dr. Strangelove. Oh, you're very, very good. Thank you. Give a big round of applause to Taylor. You know, I love Eric Breckenfeld because he's so smart. But there is something where you've got this sort of future thing around them, and and part of it, if I hadn't known you, I would have said, hey, how are we going to blow up the world with fusion? And so you're the guy. I mean, you're fusion in America, and we've seen enormous gains in fusion science. We've seen Lawrence Livermore Labs achieve a lot, and lo and behold, this week, and I think you must have timed it, the administration comes out and has made this new, very big push on fusion and Project Gemini. So tell us where we're at. Tell us where America is at on fusion, and whether you're confident or worried.
Yeah, happy to. So there's been major technological breakthroughs over the past several years. Fusion research has been around for decades, really before World War II. But over the past several decades, we had
a fusion bomb.
Well, actually, it even predates the Manhattan Project.
Okay.
It goes back to the 1910s, 1920s.
That's more detail I need. Okay.
But you mentioned the NIF breakthrough, which proved the fundamental science of energy gain. But now there's a commercial ecosystem of companies, and it's really a US-dominated industry right now. So I work for Commonwealth Fusion Systems. We're the largest fusion energy company. We've raised about $3 billion total, but the whole industry is about $10 billion. And 85% of that is in the United States. So it is actually right now a US-dominated industry. You mentioned the Office of Fusion Energy, and so we have champions across the administration. Secretary Wright is a champion of fusion. They've laid out a roadmap for how we will commercialize fusion more rapidly. One thing I think people don't appreciate is the timelines that fusion are on, because there's been a lot of history around that. But some of these breakthroughs have made fusion closer than we previously realized. So we at Commonwealth are building a demonstration machine. It's 2/3 complete, and it'll show energy gain in 2027. We're concurrently working on a power plant that will deliver electricity to the PJM market in the early 2030s. So those timelines are kind of what bring us into conversations like this one around AI and strategic competition. And then I hope we can talk about China as well.
Well, I want to get to China, but I really want for our audience, we have a lot of folks on C-SPAN in this room here who may not follow every detail around fusion. I remember going to see the fusion project at Lawrence Livermore Labs about 30 years ago. And so it just sort of seemed to be this project that was kind of like a Star Trek idea that was never ever going to get solved. And there were issues about containment facilities and all of that. Where is the science today? Do we have all the science we need?
We need more science to improve the machines, but we've made major breakthroughs. And so maybe just take a step back in case people don't know what fusion is. So fusion is what takes place in the stars, and then building a fusion machine on Earth is replicating the conditions that exist inside stars. So you have to basically heat a gas, a plasma, to 100 million degrees, so it's really hot, and you need a confinement. And so that's what we're doing at Commonwealth Fusion Systems, is building magnets to confine that machine. So the breakthroughs I'm referring to, for us, refer to the magnets. So the magnets are dramatically more powerful than what existed in research machines, and our results were peer-reviewed and validated by the scientific community. And so in terms of where we're at in the science, the scientific community generally believes that we'll reach energy gain from our machine, but we need more breakthroughs in material science so that we have resilient materials that face the plasma itself, because the materials will degrade over time. So that's one of the scientific areas that still needs further funding.
So I want to hit, I mean, part of it, we're talking about American growth, and you just said, hey, we're ahead in this, but I've seen America be ahead in a lot of things in the past, and then it ends up in Korea or Japan or India or China.
Or China.
And so now what I've taken, and this isn't from talking to you, from a lot of others, a lot of frustration in the fusion science ecosystem that it's not moving fast enough, too many delays, too many problems, and they're thinking that China is going to zoom ahead.
Yeah.
Is that right?
In terms of, well, it's a question for the US government in some ways. China is following the same playbook that they've followed for other forms of advanced technology that you referred to, that they kind of now dominate the world in. They are spending big, so they're investing $2 billion annually, so it's triple what the US spends. They are aligning state resources. They're building research facilities. You can actually see this in images from space of how fast they're building these facilities. They're building them overnight. So if people have questions about fusion, just look at what China's doing. It's in their 5-year plan, and they're also attracting top talent.
You get like the little photos from space delivered to you about what they've been doing?
We do. I mean, the U.S.
Are you like on a listserv, for that?
A distribution list of fusion pictures. The U.S. government might have fancier pictures than we do, but you can really see what they're doing. But they're also not really secret about it. They're actually attracting top talent. Researchers from Europe, UK, Germany, Japan, Spain are traveling to China to work on a project that is very similar to what we're trying to do. So it's kind of like a Sputnik moment. And for the US government, what really we have the champions across the administration, they have a vision for fusion. And so what has to happen is...
Well, tell us about that, because I think it was announced last week, right?
Yeah, so they announced an Office of Fusion. So for the first time, the DOE has a dedicated office to focus on fusion and commercialization of fusion. They also laid out a roadmap for how you would rapidly commercialize this technology and fund the research facilities that we need on materials that I mentioned. But it really needs an injection of capital. And so right now, there's a panel of experts and industry officials that are calling for the US government to spend $10 billion one time to accelerate the industry to make sure that we don't lose the race to China. And it may seem like a significant sum of money, but it's also about what the US government spends maintaining its own buildings. And so if you think about the strategic bets and races we don't want to lose to China, we kind of think it's a no-brainer.
How does AI fit into the science part of this, into kind of moving us along?
Well, NVIDIA was talking about this, about how AI can accelerate fundamental science, and so we see that in fusion as well. AI is part of the demand signal for fusion energy, so our first power plant is going to be in Virginia, which is, of course, the state that has the most data centers. We have an offtake agreement with Google, and we have investment from NVIDIA and Google in our recent round of funding. So clearly the hyperscalers, the AI leaders see fusion as part of the energy mix. But in terms of what can be done to accelerate fusion technology, we have a partnership with Google DeepMind where we are running millions of experiments on our plasma before the machine is even turned on to simulate how it will operate inside of our machine. We're also a fusion machine. There's basically a machine in the middle surrounded by subsystems, cryogenics, power systems, heating. And the AI tools will allow us to simulate the best configuration of those inputs to optimize the machine's performance.
Doesn't Virginia have enough stuff?
I think if you ask...
Can you put it like in Oklahoma or something? Or?
Maybe for the second one, but I think if you would ask them, they probably need more energy, just like everyone needs more energy.
Well, everybody needs more energy, but I'm just sort of interested in, are your plants so giant that they need giant... I mean, do you need lakes to cool down?
We don't need lakes.
You don't need lakes?
But part of why it's...
I ask this because I'm just interested in how you get a science to achieve something like you're doing. It becomes easily replicable in the country, easily distributable, without having really harmful environmental effects, and then you don't have, ugly eyesores of facility. Can you put, fusion in a box and, move it around the country?
Maybe two parts of.
I know I'm asking a silly question.
No, it's a good question, and there's two parts of my response. So one is, we actually do want to build it to scale and replicate. So we've hired folks from SpaceX, Tesla, Boeing, people who know how to scale manufacturing. And so people sometimes ask, if you want a fusion plant in Oklahoma, will you build a custom plant? But our vision is that we would build one design and scale it. So the same way that you would do in space or aviation, one design and scale it. And then in terms of the regulatory framework, it's kind of interesting because the US is actually a leader on regulations for fusion. So we're regulated separately from fission because it's a different technology with a different safety profile. And so it's kind of interesting because a lot of the conversation today is around delays in permitting. But for fusion, the US is actually a leader in regulations, and we want other countries to adopt the US approach.
You mind staying for a few minutes? Because my next guest needs your power.
Okay, sounds good.
So why don't you move over there?